Let's have a look at equations and inequations. And the basic idea of any inequation is to make what it is you're trying to find, which is usually a pronumeral, the subject of the equation or formula or whatever it is we're working with. So one of probably the most simplest equations you would have seen to start off with. In fact, you would have seen ones like this probably back in primary school, but the difference is we didn't use x then. We did things like, say, box plus 3 is equal to 6 and what goes in the box, and triangle plus circle and things like that, which I suppose is a very basic form of algebra. Now, obviously we know the answer to, but I put this up here more as an idea, to illustrate an idea. Some people think of balancing equations and things like that. I think of it like moving terms. So I'm moving things. So I want all the pronumerals on one side and everything that doesn't have a pronumeral on the other. So I want to move that 3 to the other side, and the basic rule is if I simply move a term, I change its sign, which of course is the same as saying I'm going to subtract 3 from both sides, but as I say, it's just a different thought. So when I move it to the other side, it becomes 6 minus 3, and so there's 3. Now obviously you're not going to put that working down, certainly not the level we're at the moment, what sort of equations we can solve. And then we saw ones like this, and so to undo the multiplication we did of division, but in algebra we don't really use a division symbol. We tend to use fractions instead, and then we can get an exact value straight away. I mean, this one does come out to be a nice neat number, but should it have ended up being some sort of long repeating decimal or something like that, a fraction is going to give us an exact value straight away. So that one of course is 9. Then we introduce parentheses, and 2 ways, I guess, of approaching this. You could divide both sides by 4 first of all, then solve the equation, or you could expand the parentheses out, then solve the equation. Which way did I do it? I've expanded out first. So I've got 4a minus 20 is 16, so I then want to move that 20 to the other side. It becomes 36. Divide both sides by the 4, and we've got our 9. Then the next thing we did with equations, oh no, we've got pronumerals on both sides of the equation? Oh, you're kidding me. That's all right. Again, the idea, I want to move the thing that doesn't have a pronumeral, I'm moving that to the right side. The one that does have a pronumeral, I'm moving to the left side, and I change the sign, so 3z minus z is 2z, and minus 9 minus 2, dividing by the 2. I tend to leave them as improper fractions. I don't have a problem with that. Some people are obsessed with changing them to mixed numerals. I just see that as another step of work. I mean, 11 over 2 is a perfectly fine answer there. Fractions. Blah. Hate fractions. So what we tend to do is to get rid of the fractions, and of course we do that by multiplying by the lowest common denominator, in this case 7y. Multiply everything by 7y, we get a nice neat equation we can solve. 5 and 14 of course is 19, divide by the 21. So these are all the sorts of ideas we've seen over the years. Oh, but we have this special type of equation, fraction equals fraction, where we can just cross multiply. So we multiply along the crosses to create a new equation. 3x plus 9 is 10x minus 30. And then we move some terms around. 7x is 39. 39 on 7. Remember, you can only do that, of course, when it's fraction equals fraction. Got to be one whole fraction. Okay, so then we move to inequalities. Or sorry, inequations is the more correct term, not inequality. More about that when we, in a topic or so's time, when we talk about the distinction between what's an inequality and what's an inequation. But the inequality sign will change when, okay, you're dealing with inequations. When do you change the sign? Okay, yeah. So multiply or divide by a negative. Okay. Or, as I tend to think about it, if you change the sign, you change the sign. Okay. So if you're multiplying by a negative, you're going to change the sign of all the numbers. Pluses will go to minus, minus will go to plus. So if I change the sign of all the terms, then I change the inequality sign as well. So if you change the sign, you change the sign. There is another way, often forgotten. I suppose it's because we rarely do it, but if you were to take reciprocals of both sides of the equation then the inequality sign would change as well. Okay. All right, so very basic one. Done exactly the same as an equation. It's just our inequality sign, so we've got to remember our rule. If we change the sign, we change the sign. X is less than 6. But sometimes with these sort of inequations, we ask you to, plot the solutions on the number line. So let's have a little bit of a talk about that. How do we do this correctly? So 6 is a solution. I just draw a circle there, because what we're saying is this is the boundary of my solution, but the actual endpoint is not included. So that's why we draw a circle rather than colour it in. And then we just draw an arrow to indicate which way the solutions are going. I tend to draw my arrows above the number line so I can see where it is. But what you don't do, there's some really crazy ways I've seen it over the years. Don't do something like this. I've seen people go, there's some insane reason they lift it up and draw the arrow. No. Just a horizontal arrow coming out of your circle or your boundary point's fine. Some people like to put it on top of the number line because they feel that's more accurate, because we're saying this is where the numbers are on the number line. But if you do that, make sure it's very clear that what your solution is. Inequations are a bit different, because unlike equations where we just have a left-hand side and a right-hand side, in equations we can have 3 sides. But that's okay. The rule's still the same. Whatever I do to one thing, I'll do to everything. So I'm going to move that 6. So I'm going to subtract 6 from everything. Now, to get the x by itself, I'm going to have to divide by -1. But if I change the sign, I change the sign. Now, I don't know if you're like me. I'm looking at that answer and I'm just shuddering at the moment because I can't cope with that. Are you like me? No, you don't see 1 on the left-hand side of -2. It just does not happen. Oh, that's better. Okay, so there's our answer. -2 less than or equal to x is less than or equal to 1. Okay? A solution, certainly when we're talking about inequalities, inequations, should look like the picture, if you like. Because if I was to draw that picture, this time the boundaries are included and we're between. And so you notice the answer looks like the picture. Okay? Over here, the answer looks like the picture. Look, arrows going left, the inequality signs going left. Beautiful. Yeah?
Are you going to get marked down?
It's not incorrect. So it would be harsh to mark you incorrect, because it's not incorrect. But you'll get your paper back and you'll see stains on it where the tears have just dropped. And, you know. So let us talk about the correct way of writing inequalities. Yes, I am fussy. So I get a solution like this. The correct way of writing this then would be x is greater than 5. Look, the answer matches the picture. No, not 5 is less than x. I also think grammatically it's wrong, because I'm asking you what values can x be. If you give me the second answer, you're saying, well, 5 is less than x. Well, fantastic, 5 is less than x, but what can x be? You know what I mean? It's not the right way of answering that question. The right way of answering that question is, oh, you're asking me about x? Let me tell you about x. X is greater than 5. So it's not actually wrong, but horrible. Okay, something like this one, as I was saying, when they're in between, make it look like the picture. 4 less than x. 4 appears on the left-hand side of 6. Not that. I mean, yes, technically it is correct. 6 is greater than or equal to x and x is greater than or equal to 4. Definitely not that, because that is incorrect. See, if we're saying x is greater than 4 or x is less than or equal to 6, yeah, it pretty much covers every number. Because the number 1000 would satisfy that. It is greater than 4. So you can say it's greater than 4 or it's less than 6. Oh, well, it was greater than 4. So, or is incorrect. And would have been the correct word to use if you were going to do something like that. But we still don't like it. It's just plain wrong. Wrong. Now, ones where they're on the outside, sometimes you see that sort of solution. And again, I would write it like that. X is less than or equal to 4, x is greater than, again, it looks like the picture. Less than or equal to, greater than or equal to. Okay? If you wrote them the other way round, again, it's not wrong. But look, it doesn't look like the picture. It looks messy. 6 on the left hand, no. And that's just stupid. 4 is greater than or equal to x is greater than or equal to 6. Again, is wrong. Okay? Because that actually implies and. Now, you find me a number that is both less than 4 and greater than 6. Can't happen. All right, so 1F.